Hey everybody, today I want to work through, and you can see it again up at the top there, we've got our cosine law today. To do that, I want to make sure that we're good with where we should be up until this point. So let's deal with a little review problem. I want you to solve for the missing side, and you can see there is the side labeled X. So take a moment, pause the video, and when we come back, we'll check some things out and make sure that we're exactly where we need to be. Okay? Pause it now. Okay, we're back. So you take a peek, you've got a triangle in front of you. It is not a right triangle, so you can't use any SOHCAHTOA. What do we have at our disposal? Well, we've got sine law. In order to use sine law, I need to have a side and its corresponding angle, and I notice that I have that right there. There is my side 12, my opposite side 38. That is my magic ratio. There's my pair. Perfect. For me to then be able to go through and solve X, I would need its corresponding angle. I have that. I am good to go with sine law. So I am looking for that side X. So I'm going to put that on top. And so on the bottom then, I need to compare that to the sine of the corresponding angle. And I know that that ratio is true throughout my triangle. So any other time I take a side and I compare it to its corresponding angle, then I know that it's equal. There we go. There is my application of sine law. I am hoping that you have that line down. It would be needed. And if you recall, I need to see this next line because this is the exact value for what X is. That is perfect. Now to finish it off, you go ahead and calculate that. You take a peek up to see if there's any rounding rules you may need to make a note of. I think we should be good on our keying sequence to this point. And hopefully if we round to 2 decimal places, we get 17.67 centimeters. Okay, I'm hoping that that one went pretty well. And that is going to give you a good idea whether you are comfortable or not with sine law. Okay? I'm hoping that one was good. If it wasn't, then that's telling you you need more practice on your sine law. Okay, so take that as a gauge. You make sure you make a good decision. Okay, let's jump into our next problem. I want you to take a look at the problem in B. And you'll notice that I've asked you to solve for the missing side. It's just that I didn't label it X this time. But you can see that there is this one side that is missing. I'll call it X now. So, you take a peek. It's not a right triangle, so you can't use your SOHCAHTOA. So that means we have sine law at our disposal. And you will notice a big problem. And I mean a big problem. Well, you can use sine law from the standpoint of in order to find X, you need its corresponding angle, and you were given that, which is nice. But when you go to find that magic ratio, your magic fraction, well, you have this side that's 10, but you are missing its corresponding angle, and you have this side that's 15, and you're missing its corresponding. You cannot use sine law. We are not given enough information to be able to use sine law, and you don't have the means to find it. So this triangle causes a problem for us. We don't have the means to find that missing side, at least not yet. So if you noticed when we talked about the title for today, we're talking about something called cosine law. Hey, I'll give you a hint. Cosine law is going to help us. For us to address cosine law, or use cosine law, I guess, first we have to figure out what it is, and we need to make sure that we can prove it. So let's jump into a proof for cosine law. You'll notice I did what we did on our sine law day. I went through and I drew on a triangle ABC. I want you to do the same thing on your page, and let's make sure that we do something very similar to yesterday. Yes, draw on a generic triangle ABC that is not a right triangle. But what I also want you to do is make sure it leans to one side again. Again, what I mean by that is don't go and draw it so it looks like it's almost an isosceles triangle. That's going to skew the way the diagram's going to look. It's okay if it was an isosceles triangle. That's not a problem. But I want to make sure that I don't make any assumptions as if it was. So you will notice that it's almost like I took my angle B, or that vertex B, and I leaned it to one side just so it ensures that it doesn't look like B is directly over the midpoint of that bottom side. That's all. Okay, I want to go through and deal with a proof with this one. This one's going to be a little uglier than Sine Law. That's okay, but our process is going to be very similar. So I want to make sure that we can go through how could you do this proof on your own. Okay, the first thing that we need to recognize, what you have up until this point. Like, what are the tools you have at your disposal to this point? Well, up until this point, you've gone through and you said, okay, I can solve right triangles. So you have all of your SOHCAHTOA. You have your right angle trig. You then also learned what Sine Law was. And you have those two things at your disposal. Now, I'm going to argue you have one that you never need to forget, or you shouldn't forget. You also learned Pythagorean theorem a while ago. Don't forget about that. It just so happens we tend to live in the world of trig. We tend to go there first. Okay. Those are the tools I have at my disposal. I want to try to use the stuff I have. So for me to go through and deal with cosine law using sine law, I want to make sure that we recognize what you see on the screen is also an order of progression. When you go to use tools, you should try to use the most basic tools you have. Like Pythagorean theorem is the most basic relationship you have on a right triangle. If you can't use Pythagorean theorem, then we can flip into some trig, some right angle trig, if we know angles as opposed to side lengths. If those are not accessible, we don't have the information to use them, we're not in the right environment, then and lastly, do we go through and do we look at Sine Law? Don't fall into the trap of always wanting to use your latest tool. Okay? We just covered Sine Law. That's your latest tool. Leave it till the end. Okay, I'm going to get rid of that little checklist of tools at our disposal because I'm hoping we can now just talk about them freely. You would love it if triangle ABC was a right triangle. You would love it. So just like we did with Sine Law, make it one. So what I'm going to do is I'm going to drop in a height. I could drop this height from any vertex. Visually, I'm just going to drop it in from B. But as I said, you could extend an altitude from any vertex. Okay. There is my height, and just like yesterday or last time, I'm going to call that H. I'm going to mark it as a height by marking that as a right angle. There we go. Okay, how do we start our Sine Law proof? Well, now we took a look at all the angles we had. You will notice on that diagram, you have this entire angle A and this entire angle C. For Sine Law, we went through and we created sine equations. Well, if we're going to look to try to prove or create a cosine law, then let's try to build cos. So if I went through and I now labeled all my sides based on my original triangle, I have everything on the blue. Everything in the blue was my original triangle. The orange is different. Then what I might do is let's try to build a cos equation with angle A. Okay, I'm just going to move that diagram a little bit to the left and give myself a little more room. What I could do is I could then say, well, then the cos of A is going to equal, and this becomes a bit of my problem. Cos requires adjacent. And my adjacent side on triangle AB, I don't even know what that is, so let's give it a label. Let's call that D. I don't know what that is. And you'll also notice that it's not a part of the original triangle. At the very least, it's not a full side length. So what I'm going to do is I'm going to do this, and I'm going to say, how about I just call, if I get rid of that D, this side length at the bottom, side X. Okay, I'll just call that X. The same way we dropped in a height, so we put in a variable of H. I need an adjacent side. It's not a part of the original triangle. Therefore, I'll call it X. That at the very least allows me to build this cos equation that would say cos A is X over C. Adjacent over hypotenuse. Okay, not too bad. Well, if I jumped over to my other angle, angle C, I could do the same thing. I could build a cos equation. And I could say that the cos of C is equal to, and I fall into the same pattern. Now, when I go through to do that, I could then say, hey, well, the last time I said X, then I could call this Y. But I don't want to do that. Because now I'm just starting to use way too many variables. And I don't need to. Because you will notice that rather than introduce a new variable Y, I can express the distance from below H all the way over to C in terms of X. I'm going to draw it on my diagram to make sure we're good. Are we good that this distance from A all the way over to C is side B on my original triangle? I hope so, yes. Are we good that this distance part of the way is X? Then I'm hoping that we are very good to say, well, from there till that end has to be the total minus the one we know. And you'll notice by me calling that dimension B minus X, I didn't use a new variable. B was already part of my original triangle, and now I can use the same X I used from before. That keeps things related. I like that. So up on my triangle, I'm going to call this the total minus the part we know. And there we go. Okay, if I jump back up into my cos C equation, then I know cos C is going to equal B minus X, my adjacent, over my hypotenuse. Okay, that gets me to two equations, both with coses in them. I like that. That looks very similar to what I did with my sine law proof. I think I'm on the right track. Okay, I'm going to go and do something right now. This would have been us dealing with sine law. You could have then said, hey, to get my x all by itself, I'm going to multiply out my c. This is going to look a little confusing because I now have c cos A, so I kind of have like the two c's side by side, but I hope we're okay. I could do the same thing on the other one, and I could say, hey, well, b minus x has to equal a cos c. And I start to kind of fall into what I did with sine law. You'll notice that I happen to have an x in both of those, so I could go ahead and I could solve that system. Okay, I'm going to do something that I don't want you to copy down. I'm going to do what we did yesterday or last time. I'm going to solve the system, and I'm going to solve it by substitution. What I'm going to do is I'm going to take this equation 1 and this equation 2, and I'm going to sub 1 into 2. I can see from equation 1 that x equals c cos A. So within equation 2, I'm going to sub in c cos A where I see my x. And what I just wrote there is a completely true statement. I just want you to notice it's not very useful. Like, yes, that is very good. It's true. But how does it help me? If I was to use that equation to help me go and find something about that blue triangle, I want you to notice. Let's just say I was looking for, I don't know, side A. Let's just say it was for side A. Then I would go through and I would divide out my sine C. So A is going to equal B minus C cos A, all divided by sine C. Okay, for me to find side A on that triangle, I would need to know what side B was, what side C was, so I'd need to know two of those sides. I'd have to know what angle A was, and I'd have to know what angle C was. Can I just highlight something to you? Those two right there. For that equation to be useful for me, I would need to know what side C and angle C were. Hey, that looks like a side and its corresponding angle. Well, if I already knew that, why do I need cosine law? I can just use sine law and I'm good to go. Notice, for that equation to be useful for me, I would need to know 4 properties. I have 5 variables. 1, 2, 3, 4, 5. So to solve for one of them, I'd have to know the other 4. And if I have to know the other 4, I already knew enough information to use one of my other tools. Okay, I asked you, don't write it down because it wasn't very useful. So I'm going to get rid of all of that. And I want to come back up to my equation 1 and 2, but I'm just going to do it back in my red versions. Okay, I have those 2 equations at my disposal. Now, I want to make sure that we're good that, yes, I could go ahead and I could expand out or multiply out my 2 denominators. I'm just going to wait for a second to do that. I'm not saying it's a bad thing. I'm just going to wait for a sec. If I look at that and I say, well, this doesn't seem to be that useful right now, well, then I do have the means to go through and use other information about that diagram. Remember, don't get stuck thinking about what is the most current or the latest thing you learned. Go back to the beginning. When we made a note of everything at our disposal, I haven't used one of them. What about our good old Pythagorean theorem? Okay, what I'm going to do is I'm going to build the 2 Pythagorean theorem relationships that I could build on that diagram. Look at the left side right triangle. I could then say that my one side, x squared, plus my other side, h squared, has to give me my hypotenuse squared, c squared. There is a Pythagorean relationship on the left-right triangle. I could do the same thing on the right triangle. I know that b minus x squared plus my h squared has to give me my a squared. Okay, there's a lot of stuff that I found that kind of leads me down the track of cosine law. I created cos equations, and I used my Pythagorean theorem. Okay, so we can talk about this. I'm going to label everything. Equation 1, equation 2, equation 3, and equation 4. Okay, hopefully we're good. We have down all of the red. Now we got to try something that's going to be useful. Us just going through and solving a system between equation 1 and 2 wasn't that useful. So what else could we do? Well, if I take a look at everything I have on my page, I don't know, maybe I could go ahead and I see brackets within my equation 4. How about I simplify my equation 4? Okay, I'm going to take equation 4 and I'm going to expand my brackets and collect like terms. Okay, when I do that, I'm going to square my b. I'm going to multiply those together and double it, so it's a minus 2bx. Square my x. Now I have my h squared. That is equal to my a squared. Okay, we take a peek at that, and I don't know if we think that that's that useful. Like, at least I simplified it. I just have nothing else that I can collect. Okay, I'm telling you that that gold equation was actually very useful. I want you to take a peek at that gold equation, and I want you to take a look back up into one of our original red ones. Not equation 4, because we just used it. And I want you to see if you see anything that's useful. Okay, I didn't give you much time on that. Can you take a look back up at equation 3? And when you take a look at equation 3, what I want you to do... Oh, I just lost my squared. I will correct that in a moment. What I want you to do is take a look at the left side of your equal sign. Notice you have an expression of x squared plus h squared. Take a look in your gold equation. You have that same thing. Okay, I want to highlight what's going to happen. I can take equation 3 and I can sub it into this equation 4 gold equation. If I go ahead and I sub equation 3 into this equation 4, you will notice that I can eliminate my x squared plus h squared by replacing it with a c squared. This is my strategy that I'm going to use. I want you to notice something important. When you look at that first gold line, do you notice that that x squared plus h squared were two parts that I labeled on my diagram that were never a part of my original triangle? They were things I had to put in there. So when I'm trying to work my way through to come up with a cosine equation that's useful for me, I only want parts of the original triangle. And by me being able to replace x squared plus h squared with a c squared, I eliminated two parts that were never a part of my original triangle, and I was able to replace them with something that was side C. Okay, that was really useful for me. Okay, I'm going to get rid of all those green circles. Okay, I think you have your strategy now. Take a look at my last gold line and notice that we still have one more part, that x, that was not a part of our original triangle, that if we could get rid of that and write it only in terms of our original triangle, then that would be super useful. Okay, take a look back up at equation 1 and equation 2. Those are the only two equations I haven't used. If I went through to use equation 2, notice there's an x in there. But I have this more complex expression on top of a b minus x. That means if I went and rearranged equation 2 to get my x all by itself, what x is going to equal is going to be more complicated than what I see in equation 1. Notice it's just an x. So my motivation then is to take equation 1, and I'm going to do this off on the side. There is my equation 1, and I'm going to do what we did previously. I'm going to multiply out my c. So I get c cos A. That is what x is equal to. And I can now sub that equation 1 into this new equation I have, which I'll still call 4. Okay, I'm going to slide that up a little bit. Now what I have is a b squared minus 2b. I can replace my x with what it's equal to, c cos A. I finish off my equation, and there we go. Okay, that is my cosine law. Look how ugly it is. Okay, but let me rewrite it in what would appear to be a more useful form. You notice that within that equation, you have a squared something, and then you got this big ugly term in the middle. What I'm going to do is I'm going to write it in a particular way. That way, I think, is going to be as useful to you as possible. Okay, here we go. I have my a squared on the one side of the equal sign. Nice. Now what I'm going to do is I'm going to write my two squared terms together. My b squared plus my c squared. Nice. Now I'm going to finish off with my big ugly term, my minus 2bc cos A. That is your cosine law. And that is what you need to burn into your brain. Whew. Yes, that is a doozy. Okay, I'm going to go back and put that entire proof on the screen for you. We should hopefully understand where cosine law comes from now. You do not need to memorize that proof. Sine law, you need to be prepared to be able to prove sine law. Cosine law, yeah, it's got a little bit extra to it. Okay, so I'm going to talk to you then about how you can help memorize this, or what can help to help you memorize it. But also, I want you to make a note, if we go back to our diagram, yeah, we could have had some other things in some other spots. Okay, I want to take a look at a few things. First off, you will notice that for me to go through and now use cosine law, I only need 3 things. For me to solve for side A, for instance, I need to know side B, side C. Well, that side B and that side C are the same thing as what I had before, so that doesn't require me knowing 2 new properties. And now, angle A. That means I only need 3 properties of my triangle to use cosine law. That is more useful than what we had before. Okay, also, if we go back up to my diagram for a second, remember how we dropped in our h? We created an altitude from B? Just like in sine law, you could have created an h from A or an h from C. That would have divvied up your angles in different ways, which would have allowed you or caused you to create different equations 1 and 2. Rather than breaking apart angle B, we could have broke apart A or broke apart C. That means that we would have different versions of cosine law depending on how we dropped in our height. So I want to help you right now with a way to write out cosine law. I want you to take a peek at what cosine law looks like, and then we're going to actually talk about it with its components. So what I'm going to do is I'm going to jump over to a brand new slide, and I want to walk through cosine law. Okay, all you see in front of you now is a blank screen. I've got nothing to reference back to. I'm going to build my cosine law. And what I'm going to do is I'm going to write out cosine law in the way I want you to think about it. Okay, if I have my a squared first, then I need the squares of the other two sides. Since that was my a squared, the other two are my b squared and c squared. Now, I have a plus in between. Why do I have a plus? Well, it's because, doesn't that look an awful lot like Pythagorean theorem? Now, don't be all particular about, no, Pythagorean theorem is c squared equals a squared. Sure, who cares what your labels are? It's the hypotenuse squared is equal to the sum of the squares of the other two sides. It's just that this wasn't a right triangle. So I don't have a hypotenuse. That should look an awful lot like Pythagorean theorem because it is. I'll talk about that in a moment. Then what I need is I need what I refer to as my adjustment factor. I'll talk about that in a moment. What is that adjustment factor? Well, the part I really need to memorize is the -2. Because then what I had was those same two sides, so B and C. It's cosine law, so obviously I'm going to use cos. And then what angle goes in there? The same angle or the corresponding angle for the side that was isolated. There we go. That is how I can build my cosine law. Okay, we're going to walk through this for triangle ABC, but we're going to build it a different way. What if my b squared was written all by itself? Okay, let's build cosine law. So if my b squared is all by itself, then my a squared plus c squared has to come next. There's my Pythagorean theorem. Now I need my adjustment factor, so I need -2 of those. There's my a and my c. Cos, and I need angle B because I need that to match up with my corresponding side. There we go. Nice. Okay, I want to give you a moment to see, do you or are you able to write out a version of cosine law? So let's tackle one last one. What if c squared was isolated? Okay, I want you to try this on your own and see if you can build it. Okay, I want you to pause the video now. Okay, we're back. So if c squared was all by itself, then I need my a squared plus my b squared to follow. Now I need my adjustment factor, so I need -2 of those cos of my angle. There we go. If you have the green all written down, well done. You're picking up on that pattern. That is great. Okay, what I want to do is I want to get rid of the red and the green versions, and I want to go back up to the gold one, not because the gold is a better one or anything, but it's because I want to start talking about that Pythagorean theorem relationship along with my adjustment factor. So I want us to really understand what cosine law tells us. This is going to be next level for us. Okay, this is where you want to get to once you become really good at using cosine law. Okay, I'm now going to highlight that is my adjustment. Okay, why? Well, I'm going to draw a very crude diagram down below, and I'm going to do my best. My suggestion to you, don't draw this, just follow along. Okay, if that was my triangle, I'm going to label that as like A, B, and C. That is going to make my hypotenuse side A. Don't get alarmed if you're looking at it going, but Gray, this is not supposed to be a right triangle. Just hang tight, Follow along. Okay. I hope you guys can see that triangle I just drew in orange would be something that would be very similar for what I would use for my my cosine law. I could write out a cosine law for that. That would be a squared equals b squared plus c squared. And notice that Pythagorean theorem would work on the orange triangle. A is my hypotenuse. And then I would write down that I've got my minus 2 BC cos. Now, take a look at the only piece of information I've put on that triangle. It's that angle A is 90. So, I'm going to write in 90 degrees. Okay, if I can get you to push some buttons on your calculator, I want you to actually see this for yourself. So take a moment, punch into your calculator cos 90 and see what you get. Okay, you should get something very interesting. Cos of 90 equals 0. Okay, well, let's play that through a little bit. What's the consequence of that? Well, now what that means is if that's 0, 0 times anything is 0. And notice that wipes out the whole adjustment factor, and you are left with Pythagorean theorem. Nice, that works. Cosine law works on my right triangle. Just don't ever use it on a right triangle. Why would you ever use cosine law? Just use Pythagorean theorem. Okay, but at least that gives us a little proof. Okay, I'm going to get rid of some stuff right now, and I'm probably going to lose a little of my diagram here. I'll fix it. Drop back in, move across. There's my right angle. There is A. Okay. What if I don't have a right triangle? That's the whole problem we're trying to address. What if instead my right angle was an acute angle? So what I mean by that is rather than side or me going vertical to get to C, I want you to imagine that I tipped it in a little bit. So say I got like that gold. Actually, you know what? I don't even like that. I don't think, and hopefully that didn't even show up for you, I don't think I tipped it enough. Let's say I got something like that. Okay. Well, now that means that my triangle would look something like this. And I hope that you can maybe see that gold triangle, let's call it, with a new position for C. Okay, I am hoping at the very least, if I had that gold triangle, I'll just put that bottom side now as a gold, I hope that you can see that my side A is now going to be shorter on the gold triangle than the orange. I hope that that's pretty obvious to see. Since angle A was tipped in, since it was acute, that makes its opposite side, side A, a little shorter. We can see it on the diagram. Okay, I want to play through cosine law. So, I have my Pythagorean theorem minus my adjustment factor. But now, when I take my cos of A, I'm going to have an acute angle in there. Literally, what I want you to do, working through this video, is I want you to pick any acute angle you want. Any angle that's greater than 0 but less than 90. So pick any one. Like I'm waiting for you to pick. No, but I mean like seriously, pick any angle. And then what I want you to do is I want you to punch into your calculator cos of that angle. And then all I want you to do is just leave that value on your calculator screen. Okay, if I was to pick an angle, I don't know, I'm going to pick something nice and easy. 40, I don't know, who cares? 10, 80, 89, who cares? I'm just going to pick 40. When I calculate the cos of 40, I'm going to get like 0.7660, blah, 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 blah. Let's just say I rounded that off to like 0.8. Like, it doesn't matter what I'm rounding to right now. I round it to something. I hope that we can see back up in my cosine law, the cos of 40 would now equal 0.8. So take a look and see what the consequence of that is in our cosine law. Well, that means I'm going to take my 0.8, I'm going to multiply it by C, multiply it by B, multiply it by 2, and now that whole value that I just boxed in red, I have to subtract from my Pythagorean theorem. So notice, A is not as big as it could be, as if it was the hypotenuse, because I'm taking off the boxed in part. I'm making it smaller. And if you look back at your diagram, you notice A became smaller. Nice. So what cosine law is Pythagorean theorem adjusted. It's adjusted for the triangle not being right. Okay, now I want to get to the last one, and this is the one that I think really gives us a well-rounded understanding of this. Let's say that instead of me rotating that point C inward, let's say that I rotated it out wider. Like, I'm going to rotate it really wide. Let's call that the location of C. If I now formed a triangle from that, then my triangle would now have to come all the way out here. I would not have that usual A, so I'm going to get rid of that. My A now would be the green A. And I'll just put it like smack dab in the middle so you can see it. That means I would have this as my triangle. Okay, I hope we can all see that side A is longer than the orange A, or longer than the gold A. Okay, how does cosine law show that? Well, if I went to write out my cosine law, it would be A squared equals B squared plus C squared, finish off my Pythagorean, put in my adjustment factor. Same thing now. Take a look at angle A, and you should be good that angle A is obtuse. It is bigger than 90 because I tipped that side out wider. Do the exact same thing we just did. I want you to pick any obtuse angle you want. So make that angle greater than 90, less than 180. I don't know, I'll pick a nice, neat number. How about 120 degrees? You pick any value you want, anything. I picked 120 because I happen to know something a little bit, and I just gave me a value that was easy to work with for this instance. You will notice when you punch in cos 120, cos 100, cos 91, I don't know. But when you punch in cos of an obtuse angle, something interesting should have happened. Like when I punch in cos 120, I get 0.5, but not just 0.5. I actually get a negative value. And you'll notice that's like the first time that's ever popped up. That I'm getting a negative value when I punch in my trig ratio. Okay, follow that through. What's the consequence of that? So if I go back up into my cosine law, I get negative, and I really want to write that, negative 0.5. Let's play through that consequence. Who cares about the 0.5? It's a number that's not 0. It's something. Who cares? I want to focus in on the negative. You're going to now take a negative value. You're going to multiply it by a side length, which is positive. You're going to multiply that by another side length, which is positive. And now you're going to multiply that by negative 2. So you're going to take a negative and multiply it by a negative. This whole boxed in value becomes a positive. So you're going to take Pythagorean theorem and you're going to add on more. So if we look back at our diagram, it shouldn't surprise us then that that length for A was made bigger by tipping that side outward. I'm hoping, and I know that that might have been painful for some of you guys, but I am hoping that by us having this conversation about cosine law, you now can really see that all cosine law is Pythagorean theorem adjusted. So that's what I want you to understand, and that's what we're going to work with. So if you can remember how to write out cosine law, it's Pythagorean theorem adjusted, then I think that's going to help you to know it, to work with it, and have an idea about how to check our answers when we get them. Okay, there is the end of our big theoretical discussion on cosine law. What I want to do is I want to jump back to that triangle that caused us a problem earlier. Okay, you remember this triangle. It's been a while. You remember this triangle. This was the one that caused us problems because we did not have anywhere within that triangle a corresponding side or angle. Okay, we do not fret about this anymore because we have cosine law at our disposal. So I'm going to call this triangle, if we had to go through and put some labels on it to talk about it, I'm going to pick something that is totally different than A, B, and C because I don't want us to just copy down cosine law from before. I'm going to call this triangle DEF. That way we've got some new labels in place. Okay, what I've been given is angle E. And I'm helping you in knowing that if I have angle E, then I want my version of cosine law that has side E written all by itself. So there we go. I've put down the E squared. That is enough for you to start writing out your first version of cosine law. Okay, I want you to give it a shot. I want you to write out the formula for cosine law that would work in this instance. Okay, pause the video now. Okay, we're back. So if I have my E all by itself, then I have to finish off Pythagorean theorem. So my other sides would be D squared plus F squared. Now I need my adjustment factor, so I minus 2 of those cos of the side that was isolated. And maybe you can see why I put my E squared all by itself now, because cosine law now gives me the version of E where I can use my angle. Okay, we have that, and I just need to put back in that cos E, and there is my formula. Okay, if I were you, I would write that down every single time so I can really get good at drilling in the formula. It's not something I would need to see as a formal solution, but for today, I would be doing it every time. Okay, now let's plug in everything we know from our triangle. Well, we know side D, we know side F, and we know angle E. So my E squared, I can't do anything about. I do not know side E, but I do know D. D was 10, F was 15. Now I need 2 times side D, side F, and the cos of angle E. And what you'll notice on the right side of my equal sign is I have no more variables. Everything's a constant, which means I can calculate that whole thing. If you look at the equation in its entirety, I only have one variable, E. Hey, cosine law allows me to solve for that opposite side. Okay, I'm going to take it in its bits. I got E squared. I can square my 100 or my 10. I can square my 15. Now I can put that stuff together. 10 times 15 is 150. Double it is 300. I am not going to calculate cos 80 because that's going to round. Round is going to be approximate. So I can clean that up and take my 100 plus my 325 or 225, which is 325. And you will notice there is my right side fully simplified. I can't do anything else with that right side unless I use approximates. Okay, now for me to solve for e, I need to get rid of my squared, which means I'm going to take the square root. I need to take the square root of 325 minus 300 cos 80. Okay, do not calculate cos 80 and round it off. Do not calculate 300 cos 80 and round it off. You need to show me that line, and now you need to push some buttons to give me the exact value of that. So I need you to figure out your keying sequence that allows you to do that. When you are done, your keying sequence should get you to an approximate of 16.52 centimeters. So you make sure that you can get down to that value and you should be good. Okay? I'd say pause the video now while you're trying to make sure your keying sequence is automatic. We're going to need to do this a lot. Okay? Okay, I'm going to go back and just erase some of that red. And there is my solution using cosine law. Okay, my advice to you would be, get to know what you need to show me. I obviously need to see the final answer. I also need to see that line because that is the exact value for E, fully simplified. What you show me for the rest of the red, I don't need to see. My advice to you would be show me that line, and I think you could probably jump from that line to the one I just drew the arrow to by taking the square root at the same time we simplify. If you gave me those 3 lines with stars beside them on an evaluation, you have a perfect solution. My advice to you, write down all the red lines until it feels so automatic, you can write the ones with the stars. Okay, there we go. That was the missing side of my triangle. I've got what I need. Okay, let's jump into our last problem for today. Okay, we take a look at that instruction, and that instruction says, solve for angle F. So, there is angle F on my diagram, and you will notice we run into a problem again. It's not a right triangle, so I can't use SOHCAHTOA, and I don't have any angles in there. So I don't have any side and corresponding angles to be able to use sine law. Ah, shoot. I wish I had another tool at my disposal. Yes, I have cosine law. So let's go ahead and use cosine law. So if the problem asks me to find angle F, then I want to write down the version of cosine law that has F in it. So let's do that. Okay, I want you to pause the video and try to write down the version of cosine law that would have F in it. Okay, pause it now. Okay, we're back. So if I need angle F in there, then I need to make sure side F is isolated. And as soon as I've made that decision, the rest of cosine law is automatic. That means finish off Pythagorean theorem. Now put in 2 of those, cos of the angle, and there is my cosine law. You can see your angle F written all the way at the end. Nice. What that means is, for me to find angle F, everything else in that formula needs to be a constant. It has to be known. And you take a peek. You do know side F. It was given to you. You know side D and side E. You have all 3 sides. Everything else in that formula is known. You can solve for F. Okay, I want to take you through the process of what this looks like to solve for an angle. Okay, similar to what we did before, sub everything in. There's my side F. There's my side D. There's my side E. Minus 2 of D times E cos of the angle. Okay, you do get a little confirmation that you've subbed everything in correctly. Remember, those two sides are the same as those two sides because they are adjusted. Okay, there is the variable part of my term. What that means is I got to get my cos F all by itself. So the first thing you should do with any formula is when you have it, simplify it. So I can square my 8, square my 14, that's going to give me a 196. Square my 17, that's going to give me a 289. Okay, these calculations are a little more difficult than the last ones. Now I need to take my 2 times my 14 times my 17. That is a 496 cos F. Okay, I can now collect, and I just want to show you guys something because this is going to be the most common mistake you make. Let's say that I put that together just so we can see it really explicitly. I went and all I did was just collect my 196 plus my 289. That gave me my 485. Okay, the real common mistake that you're going to make is you're going to want to put all of that stuff together. You either do it there or you do it here and you collect those two terms. I want you to make that mistake right now because I want us to see what's going to happen. First off, I want us to recognize why it was a mistake. Those are not like terms. Remember, there's my cos F. 485 doesn't have a cos F attached to it, so they're not like terms. That means I cannot collect them. But what happens if I did? Well, I take my 485 and I minus my 496. So if I make this like really weird mistake, I'm going to go maybe this. I don't know, maybe that. Okay, finish off the problem. Well, to get the cos F all by itself, I would have to divide out my negative 11. No problem. Well, look what you have. You have a little trig equation. There is your variable. That means you have to solve for F. F is your angle. So to solve for that, you have to go backwards. So F is going to be the inverse cos of 64 over negative 11. Now, I am hoping that that is screaming at you that there is a problem, but it might not be. So if it isn't screaming at you, then go ahead and push some buttons and see what you come up with. When you push your buttons on that, notice you're going to get error, and you should get error. Because look what that's saying. You're trying to tell your calculator that the cos, which is adjacent over hypotenuse, is 64 over 11. Like, I don't even care about the negative. It's 64 over 11. How can your adjacent side be 64 and your hypotenuse only be 11? My adjacent side cannot be longer than my hypotenuse. Oh, shoot. Yeah, there's your error. But I want you to notice how costly that mistake is going to be. If you go through and you make that collecting error, right? That was our collecting error. Then you're not going to have the ability to solve for F. And if you needed F to do anything else afterwards, you are done. Like dead in your tracks. So I want to make sure that we are not making a mistake like that at all. We should be good. That we can recognize that in that red, you do not have like terms. Which means you have to get rid of that 485. Now, that line we should be automatic with. Like, we don't do that when we solve linear equations anymore. So you should be good to be able to subtract off that 485. That gets us a negative 421. At the same time, let's divide out that negative 496. I just have to fill that back in again. And that is going to be my correctly isolated value for cos f. Now, if you want to write this term in, or this line in, that we now can say, well, therefore, f is going to equal the inverse cos, and I don't even care about those negatives. I am calculating the inverse cos of 421 over 496. And when I do that, I'm finding an angle, which means I need to round that off to the nearest degree, and I find that f is equal to 32 degrees. There we go. What you have then with problem 2 is you have a means to use cosine law to find an angle. Okay, take some time. Look back over your last solution in problem 1, where we used cosine law. We did that to find a side. Now, within problem 2, we've used cosine law to find an angle. Your job, get really, really good at being able to use cosine law to find properties within a triangle. Just remember where we keep that in our, decision-making tree. First, we look to see, is it a right triangle? If it is, Pythagorean theorem or SOHCAHTOA. If it's not, then I hope we recognize sine law was a lot easier than cosine law. So we want to use sine law. If that doesn't work, then let's use cosine law. Okay, jump in and get some practice and try to make that as automatic as you can. Best of luck.